In Auburn, a quiet town in central Massachusetts, you'll find the Pacachoa Golf Course. At first glance, the course is a typical one, but tucked away between the tee and green of the ninth hole is a small monument. One that reads, Site of Launching of World's First Liquid-Propellant Rocket by Dr. Robert H. Goddard. The 4-foot-tall granite monument reveals that the golf course was once a launching pad. In this episode, we'll look at how Goddard's efforts almost 100 years ago have inspired generations of rocketeers and rocket launches, from hobbyists to NASA to a thriving private sector. So here's an idea. Rockets. On a snowy March day in 1926, on what is now the Pacachoa Golf Course, Robert Goddard trekked with his wife Esther and some colleagues to his Aunt Effie's ranch. What happened next was not a typical day on the farm. The group tested the first liquid-fueled rocket. Although the results barely compared to the measurements of an NFL field goal attempt, the events of that day in Auburn, Massachusetts, launched the first of many efforts to reach space. Or to use the title of Goddard's favorite childhood book, to go from the Earth to the Moon.
For Isaac Newton, there's the popular story of how the apple had a role to play in the laws of motion and gravity. In Dr. Goddard's case, there was a cherry tree that he gave at least some credit to.
This is Rob Garner, a writer in the Office of Communications for NASA's Goddard Space Flight Center. He spoke about the fascinating, humble man whose name graces the agency's first facility.
In 1899, he was a teenager then, and his family sent him out to clip some dead limbs off of a tree. And I have a page from Dr. Goddard's notes, how he recalled that event later, that I'll take a brief moment to read some of his own description of the day. One of those quiet, colorful afternoons of sheer beauty which we have in October in New England. As I looked toward the fields to the east, I imagined how wonderful it would be to make some device which had even the possibility of ascending to Mars, and how it would look on a small scale if sent up from the meadow at my feet. I was a different boy when I descended the ladder. Life now had a purpose for me.
From that moment onward, rocketry became an integral part of Dr. Goddard's life. As a student of physics, he received multiple degrees at Worcester Polytech and Clark University, both in Massachusetts. When not in the classroom, he could be found in basement labs working on rockets. Dr. Goddard was developing his theories behind liquid-fueled and multi-stage rockets just a few years after the Wright brothers demonstrated aircraft flight for the first time at Kitty Hawk, North Carolina in 1903. After nearly 15 years of intense theoretical work, along with static lab tests, he set off for his Aunt Effie's farm on March 16, 1926, for his first rocket launch.
This rocket, I say it was 10 feet tall, but that really doesn't do justice to it, because most of that height was in the scaffolding. The rocket motor itself was scarcely larger than a roll of paper towels. And this first launch rose 41 feet in the air. It managed 60 miles per hour and landed 60 yards away. This first rocket landed in a little cabbage patch 184 feet away from where it took off after only 2.5 seconds.
After this success, Dr. Goddard was able to secure funding from the Smithsonian Institute to develop his theories and hardware to test rocketry out. That's what earned him the notice of Charles Lindbergh, who became an enthusiastic supporter, instrumental in connecting him to the Guggenheim Foundation. Funding there allowed Dr. Goddard to move out of basements and sheds in Massachusetts and into the wide open spaces of New Mexico.
The sophistication of his setup there involved small plywood structures. The launch control panel he had was 3 buttons, one to start the ignition, one to start the flow of fuel, and one to cut the flow of fuel off in the case of an emergency. So you can just imagine there's a man standing in a plywood shack, rolling wires out to a gantry, sitting behind with these really rudimentary on-off knobs. It's a fair sight different than what a launch control room looks like today.
Dr. Goddard had to rely on the kinds of parts that he could buy commercially or make for himself.
It would be akin to the skunk works that you can think of today, of just sort of scrounging up what can you put together with what you have on hand.
A sense of that spirit can be found at an amateur rocketry competition known as Big Ass Load Lifting Suckers, or more commonly known by its acronym, BALLS.
So the BALLS event is a high-altitude, research-based amateur rocketry event. The Federal Aviation Administration opens up a waiver that allows amateurs from all over the world, mainly the United States, but there were a few international competitors as well, to go and launch their rocket up to at least 200,000 feet.
This is Josh Allen, an engineering student at Oregon State University. 2017 was his team's first time at the event. As he mentions, BALLS obtains a flight waiver from the FAA that allows them to fly over 100,000 feet. This is the highest flight waiver granted to amateur rocketeers by a federal administration anywhere in the world. The competition is held every September out in a dry lake bed in the Black Rock Desert of Nevada, right after the event Burning Man takes place, which is another story.
It's like a lake bed surrounded by mountains, and when you're in the middle of the lake bed, you can look out, and the mountains look like you could almost touch them. They look like they're like 100 feet away, you know. But when you look at the map, you realize that the mountains are like 15 miles away, and you have this huge, dry, just completely flat lake bed, and it makes recovery of our rockets fantastic.
Without recovery of these rockets, teams lose the onboard data that lets them know if their rocket made it to 100,000 feet or not. These rockets being built by teams across the country are a showcase of years' worth of effort that have gone into designing, building, testing, and actually launching rockets that are too powerful to be launched anywhere but in the middle of the desert.
We wound up hitting about 80,000 feet. We went Mach 2.5, a little over 1,700 miles an hour, so like 1,700 miles an hour. We were the first team from Oregon State University to do a staged rocket, and we did a two-stage minimum diameter design that was really pretty cool and unique in its own right, like as far as rocket design is concerned.
Josh's mom enjoys telling people that he's a rocket scientist, but he really identifies as an engineer.
I'm an engineer, and so I'm studying analysis and fluid flow and chemical composition and strength of materials. And by putting ourselves in these amateur competitions and collegiate competitions, it gives myself and my teammates experience that many of us are then taking and moving into the realm of much larger rockets, much larger companies that are like very famous companies nowadays that are launching big recoverable rockets. And because of our experience working on these amateur and smaller rockets, we're getting to move up and kind of have a hand in potentially manned spaceflight, you know, so it's really cool.
The field is wide open for young rocketeers like Josh Allen, and the space race is not just for NASA. Those much larger, very famous companies that Josh mentions are private sector organizations like SpaceX and Orbital ATK, who alongside NASA are sending people, rockets, and Tesla Roadsters beyond Earth's orbit.
Well, there's a role for everyone. It requires a combined efforts of government and private sector.
This is Marc Okrand. At Orbital ATK, he works on the preliminary design of the company's propulsion technologies, including space launch vehicles. Ogren sees the importance of a joint effort between NASA and these increasingly famous companies.
The commercial marketplace can be used once the established framework has been done. For instance, the International Space Station. There had to be agreements between multiple nations on funding and science and crewing and all those things. And the private sector would have a real problem with that. NASA, since being a government agency, could go make those agreements between nations. And then we, for instance, have a contract to provide commercial resupply services to the station. We take materials up, science, all kinds of different required equipment for the crew, and then we take out the trash on the way down.
Orbital ATK developed the Pegasus rocket. Dr. Antonio Elias came up with an idea, literally sketching it on a napkin, of a rocket being launched from the wing of a B-52 and putting payloads into orbit. The first launch occurred on April 5, 1990 from Edwards Air Force Base in Southern California, and to date, the company has launched 43 Pegasus rockets.
It's a true challenge when you launch rockets. They're kind of binary. They either work really well or they don't. It's not like driving a car where you can have your turn signal burn out and, or your engine die and coast to a stop. We have explosives strapped onto us, which if something goes wrong, all the systems have to work.
For Ogren, the excitement of launching rockets, of tinkering with their very design, is just there, like it was for Dr. Elias, Dr. Goddard, or Josh Allen, marveling at the landscape as their creations take off. Almost everyone we talked to in recording this episode had a passion for rocketry at an early age. Goddard climbed a tree in his backyard as a teenager. Josh Allen still practically is a teenager. In speaking with these engineers and modern-day rocketeers, a specific toy kept coming up, one that Orbital's Marc Okrand received when he was a young boy.
I got my first Estes model rocket when I was 8.
Established in 1958, Estes Model Rockets began as a mail-order company. In magazines like Scientific American, kids could find ads for model rockets and contact the company through an order form. The company now offers over 300 rocket products. Model rocketry was first conceived by G. Harry Stine back in the late 50s. G. Harry Stine and others formed another company called Model Missiles, Inc. that lasted a couple years. Then they brought Vernon Estes along. Vernon designed and produced the first production-capable model rocket, and they called it Mabel.
Mabel is still around, although not quite as functional as it was back in the 50s.
This is Michael Fritz, Director of Product Development for Estes. He's been with the company for over 25 years.
The late 50s, early 60s was the beginning of the space race. When Sputnik was launched and captured the attention of the world, I think that's kind of when budding rocketeers of any kind kind of got the urge to launch their own small versions of these things.
Once Estes partnered with various hobby retail distributors, sales really took off.
Once it got into a model hobby shop, where you had airplanes and plastic models and trains, here you had a new edition of something that it didn't take kind of the skill that flying a model airplane did or the dedication like a plastic model, yet they could enjoy some kind of flight activity that did require some assembly, finishing skills. Then they got to launch this thing a couple hundred or 1,000 feet in the air.
Fritz hears from engineers all the time who use the model rockets as children. Some he even calls born-again rocketeers, or BARs.
I probably receive a half dozen phone calls per week, usually with questions from fellows who did this activity when they were younger. They're coming back into it. The questions range from, does it do this? Is this is the model I had when I was a kid. Is it still available? Do you know where I can get this? My part is broken. Can I get this fixed?
And Fritz has also heard from others who have said that model rocketry specifically led them to a career in engineering.
Many of the engineers that we come in contact that are in the space industry have passed through model rocketry. They all have interesting stories of how, probably best to say it, of how they experimented with model rocketry when they were kids. We've had astronauts that passed through it. On occasion, we've actually had contact with some of them. They all come back and say, oh yeah, I did that as a kid. That's what led me down the path to become an aerospace engineer or to become some type of aeronautical engineer or to get an engineering period. Many times the exposure also led to an interest in just science in general, which led them into teaching or some other discipline.
According to Fritz, the Estes company has about 30,000 teachers across the U.S. using their rocket products in the classroom. As model rockets continue to inspire the engineers of tomorrow, Rob Garner says a familiar name is still guiding the engineers of today.
The center director at NASA's Goddard Space Flight Center, which bears Robert Goddard's name, likes to close his presentations with one of Dr. Goddard's quotes. It is hard to say what is impossible, for the dream of yesterday is the hope of today and the reality of tomorrow. And I think that's something that we tend to think about and hold in our hearts and our heads throughout all the work that we do here at Goddard, because it is the dreams and hopes that we will be turning into reality. It's an inspirational statement, and it's with us whenever, for most of us, for me at least, it's with us anytime we come to work.
This has been an episode of Here's an Idea. I'm Billy Hurley for Tech Briefs Media. For more news about innovative technologies, you can follow our stories every day at techbriefs.com. Here's an idea. Send us feedback to feedback@techbriefs.com and let us know what inventions you'd like to hear more about.